Now, in this video, we are going to take up one more problem on projections of laminas. The problem reads as, draw the top and front views of hexagonal lamina of 30 mm sides, having two of its edges parallel to both HP and VP, and one of its sides is 10 mm from each of the planes of projection. The surface of the lamina is inclined at an angle of 60 degrees to HP. So, how to analyze this problem in 3D and how to solve it by using the sketchbook. So, to do that, first, we'll go for the initial position. So he says that a hexagonal lamina of 30 mm side, having two of its sides parallel to both HP and VP, and one of its sides is 10 mm from each of the planes of projection. So what does it mean? 10 mm plane from the planes of projections means it is 10 mm above HP and 10 mm in front of VP. So that means the side is not resting on HP. It is above HP by 10 mm. So, the side which is resting on HP has to be perpendicular to VP. So, how to take that? The initial position of the problem should be how it should be perpendicular to VP. That is what we have taken here. So, the initial position, you can see that the side is resting on HP is 10 mm above HP. You can see that it is 10 mm above HP. So when you look from the top view, that image falls on HP. So when you look from the front view, it is 10 mm above HP. So that means this hexagon should be above HP by 10 mm. So what is the position of the surface with respect to both HP and VP? The surface is parallel to HP, so you are getting the true shape in HP, and the surface is perpendicular to VP, therefore you are getting a line in VP. So as you look from the top view, A to B, B to C, C to D, D to E, E to F and F to A are visible. So when you look from the front view, A, B, C is near to the observer, so A dash, B dash, C dash is visible. D, E, F and is away from the observer, therefore D dash, E dash and F dash is in bracket. So this is how you will be able to write the initial position in 3 dimensions. So now how to solve this by using the orthographic view. So first we are going to draw the XY line and you mark VP and HP. So as we know that it's a hexagon has to be, two of the edges should be perpendicular to VP. So you draw one particular vertical line in the horizontal plane, and by using the compass you measure the radius of 30 with on this vertical line. You draw a circle of 30 mm side of radius. So the diameter we are going to cut at these 2 points, and you mark those 2 points as B and E. With B as center, taking the radius of 30, cut in the circumference of the circle on the left hand side and also on the right hand side. Similarly, with E as center, taking the same radius of 30, cut on the circumference of the circle on the left side and also on the right side. You mark these points A, C, D and F. So then join A to B, B to C, C to D, D to E, E to F and F to A with a dark line. As he says that two of the sides is parallel to VP and also 10 mm in from the reference planes of projection. So initially I am going to take 10 mm above HP and I am going to draw a horizontal line and project from A to F, AF, draw a vertical projector of AF and CD to the 10 mm above XY line. Similarly, from B and E also you draw a vertical projector till to the 10 mm above XY line. So then, as you look from the front view, A, B, C is near to the observer, so A dash, B dash, C dash is visible. D, E, F is away from the observer, so that becomes invisible. So D dash, E dash and F dash is in bracket. Then join A dash to B dash and B dash to C dash with a dark line. So we are able to write the initial position of the hexagon in both in the top view and as well as in the front view. In the front view, the entire surface is above HP by 10 mm. So what are the positions of the surface? The positions of the surface is parallel to HP and perpendicular to VP. Therefore, you are getting a line in the front view. That is what you are getting here. And also, you can see that it is 10 mm above HP. All the sides are 10 mm above HP. That is what we have shown here. Similarly here also. Now he says that the surface is inclined at 60 degrees to HP. So that means it is keeping C dash D dash on above HP by 10 mm. Then when you wrote, you can see here, this is the surface is also has been parallel, that is above HP by 10 mm. So where you can see the distance above HP, when you look from the front view, that distance is seen in the vertical plane. So that is the reason why you have 10 mm above HP here also. I am keeping C dash D dash is above HP by 10 mm. Then since he has given the inclination, so you are rotating this in 3 dimension from CD. You take CD which is above HP by 10 mm, then you rotate that surface such that it becomes an angle of 60 degrees with respect to HP. Once you get 60 degrees to HP, what happens in the position with respect to VP? The position of the surface with respect to VP is still perpendicular to VP. Therefore, you are getting a line in the vertical plane. So then you need to transfer all these points. So C dash and D dash is in bracket. Then C dash to A dash, F dash. So you can see here A dash, F dash. So what I am doing is since I am rotating this line by an angle of 60 degrees. So correspondingly the points also moves on that particular direction. Similarly, when you look from the top view, it is projected onto the horizontal plane, which is A, B, C, D, E, F. Okay, that is the image what we are getting. Then this side which is now, so this is how you will be able to analyze it in 3 dimension. Now I need to write the orthographic sketch. So to do that, so I will draw a horizontal line which is above HP by 10 mm and consider any point on this line, and you mark that point as C dash and D dash. So by using the protractor with reference to the C dash, D dash, you measure an angle of 60 degree with respect to the horizontal and then draw an inclined line. Then you measure the distance from C dash to A dash with C dash as center, cut an arc on that 60 degree line. So you mark those 2 points as A dash and F dash. Similarly, with reference to this C dash and B dash, from C dash you transfer it onto this side and you mark that point as B dash and D dash. And similarly here it should be D dash. So now I need to write the top view. So to write the top view, draw a vertical projector from A dash and F dash and draw a horizontal projector from A and F. Both these 2 lines will going to intersect at these 2 points. You mark those 2 points as A and F. Similarly, draw a vertical projector from C dash and D dash and draw a horizontal projector from C and D. Both these 2 points will going to meet at these 2 and you mark that point as C and D. Similarly, draw a vertical projector from B dash and D dash and draw a horizontal projector from B and also horizontal projector from E. So both these 2 lines will going to intersect at these 2 points and you mark those 2 points as B and E. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dot line. So once you do that, so now we have completed the second position front view and also the second position top view. So what is the position of this with reference to both HP and VP? The surface is inclined to HP at 60 degrees and it is still perpendicular to VP, therefore you are getting a line in the vertical plane. Now the C dash D dash is above HP by 10 mm. The same C dash D dash is also in front of VP by 10 mm. Then only such that all these 2 parallel sides will be parallel to both HP and VP in the final position, obviously. So you cannot rotate this AF in the clockwise direction because it should be, if you rotate it clockwise and keep it 10 mm in front of VP, that means it will going to take A and F. But I want what? The side which is above HP by 10 mm is also in front of VP by 10 mm. So that is the meaning. So for that you have to keep CD in front of VP by 10 mm. So by rotating it in counterclockwise direction. So to do that, now here you can see this in 3 dimension. The above HP by 10 mm is parallel to HP but perpendicular to VP. I want to make this line also to be parallel to VP. So I will going to rotate this in counterclockwise direction such that the CD is in front of VP. When you look from the top view, you can see that CD is in front of VP by 10 mm. So when you look from the top view, all the points, that is A, B, C, D, E, F, all are being projected onto the horizontal plane to get the view. Similarly, when you look from the front view, that image will go to fall on the vertical plane. So you can see here A dash, F dash, similarly from E dash and B dash, and similarly from C dash and D dash. So we are projecting from here. So that is our main concept. So the corresponding points will going to be represented on the vertical plane, which is going to be the image of this. So, how to do this in orthographic view? So what I need is the edge which is above HP by 10 mm is also in front of VP by 10 mm. That's what he says. So, but at the second position top view, the edge which is above HP by 10 mm is perpendicular to VP. So I need to make that line parallel to VP, point number 1. And the point number 2 is I need to keep that is in front of VP by 10 mm. How do I know that? You can see here, this is the distance what we are talking about, which is 10 mm in front of VP. So, but however, we have not shown the dimension here, but we have kept 10 mm in front of VP. So that means I am rotating the second position top view in a counterclockwise direction and keep it in front of VP by 10. So to do that, how to do it manually? So from XY line you measure 10 mm and draw a horizontal line parallel to XY. Then you take the distance from C to D by using the compass, and you consider any point on the 10 mm line and mark this point here. So you mark this as C and you mark this as D. Through C, with reference to the horizontal, you measure an angle of 90 degree and draw a perpendicular in the top view. Similarly, with D as center, with reference to the horizontal line, you measure, with the D as center, you draw a line perpendicular to this. Then, you measure the distance from C to A and also from D to F, both are equal, and transfer it from C to this side and also from D to this side. So, AF will also, then you mark these 2 points, AF. Then, you measure the distance from C to this point, which is the same as from D to this point. So from C, you mark that on this vertical line and draw a horizontal line and extend it on either side. Then you measure the distance from this point to E, which is that point in the third position, that is this point. So from this point, you measure the distance from this point to E. So transfer it from this point to E. You got this point and mark that point as E. Similarly, you measure the distance from this point to B and transfer it from this point to B. And then you mark A to B, B to C, C to D, D to E, D to F and F to A. Then join A to B with a dark line, so B to C with a dark line, C to D with a dark line, D to E with a dark line, E to F with a dark line, and F and A with a dark line. So now we can see the side which is above HP by 10 mm is also in front of VP by 10 mm. Then draw a vertical projector from AC, DF to the front view and draw a horizontal projector from both A dash and F dash and also from C dash to B dash. So you mark these 2 points, you mark this as A dash F dash and you mark this point as C dash D dash. And then draw a horizontal projector from both B dash and E dash and draw a vertical projector from E to this point, similarly from B to this point. Then you mark those 2 points, those 6 points, that is A dash, B dash, C dash, D dash, E dash and F dash. Once you mark that, then you join between A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash and F dash to A dash with a dot line. So this is how you will be able to analyze this problem in 3 dimensions and also solve it by using the manual sketch. Finally, what is our takeaway here? If you try to analyze this problem, he says that the hexagonal lamina of 30 mm side is resting on one of its sides such that that side is above HP by 10 mm and in front of VP by 12 mm. And then the surface is inclined at an angle of 60 degree with respect to the HP. So since we have incorporated all the data which was given in the problem has been solved by using considering this, and hence our problem is right. So this is how you will be able to totally analyze this in 3 dimension, and whatever you are getting here, the same thing we are getting here. So, and how to solve this problem? By manually in the sketchbook. Thank you.